Yeah, okay, let's get started. So I'm going to attempt a live stream of solving this crackme that was posted in a Facebook group. So this is the files we were given. So yeah, I've never looked at this before, so I have no idea if this is going to be easy or hard. I guess if it takes too much time, I'm just might give up, but let's give it a go. So let's download these files. Maybe I should increase the size here. Okay, so we have some rules and info. Welcome to my Super Mario Cracker Keygen me. Okay, so we have some rules here. I accidentally wrote some code to wrap the rest of the code, but unwrapper is miscoded. Can you fix it? Otherwise crash. Okay. If you fix the above, it may happen that the application crashes. Fix. Okay, get the valid key from the application. This should be the easy part. Writing a keygen for it might be harder. Okay. Remember, fishing for keys isn't very hard, by the way. Try to use standard alphabet, otherwise the app might bork. Okay, so sounds pretty fragile. Okay, so let's just check. So this is a 32-bit Windows executable. So I will be using. I have this virtual machine for some of the analysis, and then I have this one for the Windows virtual machine for the dynamic analysis. So I guess let's just see that there's nothing sensitive in here. I'm just going to transfer the file over to the Windows computer, so we have it there for running dynamic analysis as well. And if you have like any, I don't know, questions, comments, hints, whatever, you can just write in the chat. I'll try to look there as well. Or if there are any issues with the stream. Okay, so there we have it. Okay, well, let's try to just run the program, see what happens. So I will be using X64 debugger for some of the dynamic analysis. It's a nice debugger. So Okay, so we try to run it and there's some kind of exception and it crashes. So let's take a step back and just look at what we're dealing with here. So I'm going to open it in IDA. Okay, there's not a lot in this program. We have this start function, which seems to be okay. There's some kind of packer here, so it's let's see, it gets this address. Yes, so there's some data here, and it loops over the data, 600 bytes, and adds 20 to it. So, and then it will like initialize the program. So, okay, that's interesting. So if we look again here in the debugger, we can see, take a look here where it crashed. So it crashed because it tried to oh, this is, what do we have at this address? Let's look in, follow it in dump. Okay. And we take a look again here in the study code. So it crashes here. The first time it tries to access this, there is a crash. So why is this? Let's rerun it from the start. We get the module handle. We have move forward. We reset the EDI register, and then we get into this loop part. And here so there's an access violation here. Is this, if we take a look at this section, oh, okay, let's just double check that at 401. Maybe the segment is not writable. That might be an issue. Just gonna double check that I'm looking at the right place. Okay, here. So yes, that's probably the issue here. We are trying to write to non-writable memory, and that will not work. Let's see, can we just change this here? Sets page memory rights. If we do it like this, Okay, so that works. And if we now take a look at this location, following the dump here, we can even look if it looks like it's, oh, it's down here. Okay. So let's see if this turns into something reasonable. Starting to look like something that could be code, possibly. So let's just go set a breakpoint here and let it run all the way. Oh, no, that was a mistake. Let's do this again. Set the breakpoint here. Check the permissions. And then we can okay, so it crashes again down here. Okay, so let's run this again and see what happens. We'll fix up the. At this point, maybe I should like make a new version of the executable to try to not have to do this every time. So we'll probably get to that point pretty soon. So what was the initial address that we looked at? 403. It was down here somewhere, right? Set the breakpoint here. Oh, okay. So this is somehow much more stressful when you know you're streaming this and people look at you. But I will hopefully find out something eventually. Okay, so let's look at this function that we are calling. Fortunately, the Windows API documentation is usually excellent. So okay, so this function creates a dialog box, not too surprising. So let's see, you're supposed to have like 5 arguments, which seems to be the case, and those are let's see, instance to the module. The template is this one, right? Okay. And okay, so so this looks strange. Why? Okay, I'm just reading this in the wrong direction, of course. So let's put a breakpoint here, which should be. Wait, where did it go? Oh, okay. So is the address off by 1 then? Let's see. We continue. Oh, okay, now we get. Okay, so the disassembler acts a little strange here because the address we are at is not really properly aligned. Now we are. So let's see. Either this is a mistake, since we're kind of like looking for some kind of mistake in this code. So let's see if we can just nudge that pointer one step. So maybe it's like an off by 1 thing. So let's go down here and you push that last argument, and we modify this to, let's say we decrease it by 1, and then we go there, and that looks reasonable. We have an initial jump in the function. We put the breakpoint there, we continue, we get to the breakpoint, and then there is some kind of exception. Okay. So what's going on here then? What's this? What instruction is that in? Now I'm really exposing myself here. Does that... Okay, store string. So is the EDI value reused? Because then maybe we have to actually make sure that one is correct as well. So yes, fix up this. What if we... What does this look like? Yeah, this crackme is a little bit different than what I'm used to, so we'll see where this goes, if it goes anywhere. So no, wait, no, I forgot the breakpoint. Oh. Okay, we do this again. We go down here. Let's just decrease that. I don't think that value is retained anyway, so it shouldn't matter. But let's assume this is off by 1. Go there, set the breakpoint, continue. We get here. Okay. So this goes down here. Okay, this is and here something's wrong. These instructions are very strange stuff. What are those anyway? Why couldn't we start on using a RISC instruction set instead of having all these? Decimal adjust AL after addition doesn't really sound reasonable in this context. So where did we go wrong? Maybe actually this loop should have gone on for even longer. Like if we look at let's look at this data. No, but it does really start at an even address. It's kind of strange. And it goes down here to A0. So let's do this again. Make sure that all of this data is covered by the loop. Oh, right. So here, or actually we can just calculate this. So this goes from okay, so A2 is the last offset there, and then we have 42, which is 352. That's not what's used here, so maybe that's a problem as well. Maybe we should actually loop over the whole data. Let's look at this, if anything looks, because like it could be that some of this is code and some of this is data, but if we look at this, nothing really looks like some like structured data or anything. So maybe this value here is just wrong. So let's go all the way up to 352. Let's see, we can change this here, right? Oh no, actually this goes on for longer. This is in hex, so yeah, maybe this then this probably destroys. Oh no, okay, then we have stuff down here as well. Okay, so this here is something that looks like the end of this part. Okay, so there are two possibilities here. Either we should just cover this or this as well. Okay, let's go with the first idea. So we change the loop, and then we run this. Oh yes, fix the and let's look here in the disassembler. I mean, it doesn't really look correct at all. And that initial jump when we yeah, that initial jump when we decreased it by 1 seemed much more reasonable. So first of all, okay, so how far is 600? 12.9a. So the original loop goes down like in the middle of here somewhere. That's also a bit strange, right? So, and this function, so does this function make sense to start with? Well, maybe, kind of. It's like, so maybe this function shouldn't be modified. Yeah, so we tried. We'll decrease this to yeah, this 160, and we also will modify the offset because that seems really strange that it would be an even address. Or like an yeah, it should probably be okay. So let's go for 160 here. Disable this breakpoint, run down here. Where is that address in here? 11A. No, okay, so maybe the offset is actually correct, but the loop runs for too long. That's probably what's the problem. Okay, so let's do this again. We change the loop to only run for this far. We fix up the writes, and then we run this down here. So that means oh yeah, now we're off by 1. We actually did modify the first instruction of the function, and that's maybe, let's see if we go there. Disassemble. This is a bit strange though. Let's see. What kind of memory region is this? Yeah, that's very strange. Yeah, so this code is actually very strange. So maybe the loop isn't too long at all. Maybe that code should actually be modified. So let's check our assumptions here again. What if this whole thing is actually supposed to be modified like we originally, or like I said before? So that would be all the way up here. So maybe it's too short. Let's check that. 292, and we fix the so what other possibilities could there be? Like this offset here could be off as well. And now it's time to, I think, fix this. I think I have what's called PE. I want to like edit the header for the program to make sure it's like I don't have to change the permissions every time I restart it. And I haven't done this in a while, so but I think there should be. Oh yeah, I disabled the internet on this virtual machine, so. But isn't, let's see. Oh no, that's, maybe we can just do it in my favorite hex editor. Let's see, we open this up. So I really like this editor, 010 editor. It has it's like a file format aware so this is interesting. here is a message from the author. Xvpz was here editing. That's interesting to know. Oh, so maybe this refers actually to this point too, that this. Oh, do we? Okay, so there's a lot of stuff in this file, and yeah, okay, that's the stuff we see here, and it looks not very interesting at first glance. What permissions did we have there? Okay, so maybe it's just like a way of putting in these 4 strings to create the message, but okay, so where in this do you define here? So we should be able to edit this and then resave it. Version 2, and then copy it over again to the Windows machine to run this one instead. This this was actually a little more tricky than I had anticipated. I might have thought that this would have been easier. Let's see if this worked. Yes, this worked. So okay, we could edit the header. So now if we run this, yeah, it crashes later. So what if the error is that this constant that we are working with is wrong? Like maybe this shouldn't be 14 or like 14 in hex. So that's a little bit tricky though to know what it should be. Maybe something like silly that the author mixed up hex and decimal. So 14 in hex is 20. So like if we put in 20 here instead. Actually, it kinda almost makes more sense. So maybe we should try like the proper way to do this now would maybe to like run this more systematically and try different values here. So maybe I'm actually going to do that. Let's just like first try some easy stuff, like maybe it's just like off by 1. Okay, not +1. So what if it's like the other direction? Okay, that's not it. Okay, so then we will actually have to do something. We can use unicorn for this. So we will just run a little thing. We will write a small script that takes this code, tries all 256 possible values, subtracts that value, and try to disassemble it with unicorn. Oh, sorry, I mean capstone. Unicorn is for running stuff. So using capstone to disassemble it, and see what makes sense, if anything. And I don't use this enough to remember. Yeah, so we'll just do something like this. So we're gonna read in. Maybe I should increase the text size here as well. So what is this called? The program is called this. We read in this file, and then we need to have the correct offset. So we can focus on the area, like at the entry point. We don't need to work with everything. So this is at 582 in the input file. So let's take a few bytes from there and try to disassemble it. So this looks like the unmodified version, right? Yes. Okay, so we're gonna try a few different alternatives. So for every possible value between 0 and 256, we're gonna do we're gonna subtract that value, and since just to not have to handle special cases, we'll just wrap around it. 256. Okay, so here we have something possible, and base address, this is this argument here. So maybe we print some kind of divider between each attempt. Let's see. Okay, so that works. Oh, we should maybe say what we're trying right now so we can see what looks reasonable. Okay, so we can actually try a bit shorter part of the code. We just need maybe 16 bytes or something. Hopefully, something just hit me that the reasonable thing is that the function starts with a function prologue. So something like this looks very reasonable. Let's see just like if there's anything else. No, but that feels pretty good actually. So what did I say? 22, which is 16. So okay, it was off by 2. Wow. Well, at least we did something like methodical and felt good about that. So we'll change that to this, and okay, let's do this. We change this to 16, and then maybe we should increase this as well. Like, what did we say? Or let's not for the moment. We'll go down here. Oh wait, did I? Oh shit, I subtracted. We're going to add. So it will actually not be 22, it will be something else. So reasonably it would be like, I'm a little bit slow today. It should be something okay, so 236, could that be? And wow, we have a program running. Awesome. So I guess the first 2 steps are done at this point. So let's just recap what we did here. So there is in the program there is a packer or an unpacker. Before the program runs, it has this loop where it loops over the bytes, adds a value, and then it will instantiate this dialog box with this data. The problem is that this constant here is incorrect, so we had to take out all the data, try all different possible constants here and see which one creates reasonable code. And since we're looking for like at the enter point of a function, like a function prologue, it's a very reasonable choice. So we're really looking for this push EBP, move EBP, ESP thing. So by doing this, we could replace this value here. The problem then is that the section that this resides in is not marked as writable. So if we try to do this, we will get an access violation. So we had to go in a hex editor and modify the section header to make it writable. And with those 2 changes, the program runs. So we're actually going to hard code this change in so that we can just run this more easily. So let's see if oh no, now we're doing this on the old version. So let's do this. Let's close this one. Let's open this one with the modified header. Let's go here. Let's try to build a patch. Oh no. What did we say? EC, right? And thank you, Matthias. Okay, this is usually very flaky. So actually, we're just going to use another program because so we're going to use Binary Ninja, and fairly new like disassembly, like reverse engineering platform. Okay. Which seems very promising, but I haven't used it a lot so far. However, the binary patching features of it is very good. So we're gonna whoa. Okay, now I'm really fumbling around here. Oh, okay, that's how you do it. EC, and then we save this as version 3. So pretty easy, unless you do strange mistakes like I do. Okay, new attempt. We open version 3 here, and we just run it, and we get a window. Nice. Okay, so now we have like completed the first two steps. So now we're actually going to like solve the actual crackme. So to do this, it would be nice to be able to like statically analyze this algorithm. I guess we can just like put in Kalle, hello, check. So serial has to be at least 3 characters long. Serial has to be a total of 20 characters. This might also be because of bad serial. So, and there's a about thing and a window. Okay, so let's do this. We run the program until it's loaded, and then we can try to dump the unpacked dump the unpacked program from memory. So let's see if I did this correctly now. We can just try to open the dumped version. Okay, nice. So now we jump to this function here. Okay, cool. We have something that looks very reasonable. It's setting up the window. So we have some functions here. Let's see, we have some string here. So here is a string that says like congratulations, and it's used here. So it basically compares these two buffers and check if they are the same. Okay, so that's interesting. So where is this? We can then actually we can call this function like check serial 1, and we'll see where it's called. So it's called here. So let's try to see what these functions. Okay, here we have some kind of manipulation of the input data. That's very interesting. Okay, so here we get the input fields from the dialog, and okay, so let's just double check the arguments here. It kind of looks like we have the dialog handle, like the ID of the field. Maybe this is the length. We should double check that. Max count, yes, indeed. So we take out the input, like the name and the serial. We do something about it, and we check that some condition is set, and in that case, the serial is valid. So let's see what we're doing here. This is just some counter, and this is like the input string. So this is basically just like oh, and this is in the EDI register. So these, like, this is not this decompilation is not really truthful, but this is basically checking the length of these two. Let's not do it with decompilation, because it's not like this program is possibly written like in assembly to start with these functions. I think it was hinted somewhere in the description or when the person originally came with this. So okay, cool. So basically here it's checking the length of the input, and so we saw in the function that the result is actually stored in EDI, not in the usual return register. And then, like, if it's not good, you get the invalid thing here, and the same down here. So I'm gonna go ahead and name this. What did you call it here in the program? Name. So input name, and this is in input serial. Okay, so we have the inputs. And then we call this function, which does some processing of the inputs. Here we can possibly do it like this. So, oh, I actually seem to have 11 viewers now. Wow, didn't know people wanted to see this, but where were we? Yes, this function processes the input, So it seems to be like looping over stuff and picking out things from tables. If this is probably an offset, can't we? Ugh. So yes, these are also tables where we look up stuff. Okay, nice. So let's try to figure out where the inputs are. Because I don't think they're really past in the usual calling convention. Maybe they are. Or maybe they're just picked out. So where is this referenced? And this. Okay, this is all the same table. We'll just name it string table 1. So basically the input to this function is just the length of the name, because we take the name here, the input is saved in EDI is not modified, we go into this function and then we pick out stuff from the table. So that's how the name affects this function, I guess. So this is like name len. So what we're doing, we're picking out stuff from the table using the name length as an index. And then this thing. Okay. Okay, so it's also indexing in the table, but a minus. So this is more like because these are like basically like +0, +2, +4, and then -1 here, which kind of makes sense then that they require the length to be a certain at least 3, and what do we have then? Okay, so then we're like we're setting up, because like all this stuff is like a continuous part of memory, and I guess this is what we're checking against then afterwards. Yeah, and okay, I don't understand why they have this like off by 1 thing, but okay, maybe the first character of the serial doesn't actually matter. So we're gonna call this like target serial, and make this an array 1, 2, 3, 4, 5, 6. Yeah, so this is gonna be 19 bytes. Okay, that looks better. And same thing now with the input serial, we're gonna make it a 19-byte array. What does this look like? Okay, so we're basically comparing the input serial against the target serial, which we then generate here. And okay. Oh, no. Nice. So here we can see like we're setting up this whole 19-byte array for the target serial. And there are some dashes in the serial, like you usually see. And then I guess these parts are a little bit mysterious. Like they're quite a bit from the table. On the other hand, this counter will count upwards. Okay, so like the overall structure of this algorithm is like basically we start out by taking the length of the name and picking out 4 characters from the table down here. So for example, if the length is 3, we will pick out index 3, 5, 7, and 2. Let's just write some notes here. So length 3 will be so that would be, just copy the first part of this here. So we would have like 4, 6, 8, and 3. So the first part of the serial would be 4683 dash if we input like a name like this, I think. And then we do this loop here where we look at the fourth character of the input serial and find it in the table, and then we use this as an offset to pick out the next 3 bytes here, and then we do where does this come from? Oh, that's from the name. So we use, and then we do the same thing here. So this is the fourth character of the name. You look it up in the table to find some more characters for the serial, and then finally we just pick stuff out, like we look up the previous things we have generated and use that to get another serial. So it's not really a complicated algorithm. Now we just have to figure out a reasonable way of generating this. So we should like simplify these parts here by actually understanding, because what this really is not just some random offset. It's more like the table minus something, all of these, and the same goes for this one. So okay, anyway. Sorry about that. People nagging me about playing games. But let's finish this first. Okay, where was I? So this thing here is a negative offset into the input, into the lookup table. So it's just like the difference between here and here. So we have 50, okay. So this would be the table minus 50, and this one here is 60. Okay, that's like sounds like consistent, or like there's some kind of pattern. And then D7 52. Just when I thought there was a pattern, but okay. 52, right? Okay, and then there's this one down here. 1FD. That's 14. Okay, so do we know all the things? This one, this is the fourth character of the input name, right? Yes. So we could basically just translate this into Python. I think I will do that. So I'll just like copy this over as a so we'll create this keygen.py. we'll use this as like a reminder. So our input is the name and the serial. But actually, like, since we have to, I mean, for this to ever be accepted, this value has to be this value. So this whole thing will be constant, and this thing here is like the input serial here, of course, has to be the same thing as the target serial thing here. So these two basically just the same. So we don't care about, like, the target serial is only depending on the name, and actually it's dependent on the length of the name and the fourth character of the name. So let's start here. First, yeah, we need to copy out this table as well. We're gonna need that one. So we'll fix this up. Okay, there is our like lookup table that we will use. Nice. And then we'll look at code again. So first we will use the name length okay, so we should probably like verify some steps of this. So let's just do a sanity check here that we are not completely off. So if I'm not wrong, the first 5 characters of the serial, if I use the name Kalle as in the name, this should be 68J5 dash. So let's go over back to the debugger, and we put a breakpoint in the correct place. So this will be at around here. So down here, this is like the first part of the Keygen algorithm. So let's put in Kalle and we do a check. Okay, something's wrong. Okay, the serial is supposed to be 19 characters. Okay, we get down here, and the generated serial so far is 68J5 dash. Nice. We're on the right track. So let's like cut this up in blocks. So let's move on to the next part. We are looking for the index of the dash character, basically here. We're taking the fourth character of the input serial, but it has to be the same as the target serial, of course. and then we use that to look into the table. So we'll do just gonna like sanity check this. Oh, it's not found. Okay. Yeah, it's true. The dash is not. Okay. So some assumption I made here is incorrect. Why is this? Aha. Oh, wait. Let's look at the assembly here, so we're not tricked by the compilation. Actually, let's just check what happens in the code here, because I'm a little bit confused. So we start at the beginning of the table, we load the first character into it. EDI is 0. Yeah, so it's actually using so it actually is using the 5th character of the input serial. And now the loop should break here. The question is then, why doesn't it have to be the target serial? Oh yeah, actually here in the check serial thing. So there is something strange going on here, because it feels like this Okay, anyway, let's look a little bit at what it's doing then. So it calculates this index, and I have some kind of misunderstanding how that's done, but anyway, assuming we have this index, in this case like it's 8f, it then uses this to generate a few more bytes of the serial, and this does this loop thing again, this time and then it loops a few more times. Okay, okay, let's think this through again. If, let's say, I start with what I actually think will be the beginning of my my serial. So 68J5 dash. Then we can do so we have 16 characters divided by 3 dashes. So we do a check. What happens now? So this shouldn't terminate the loop at all. Oh, yeah, so it continues until it gets to the input serial again, and then we get the B1. Will that make sense then? No, that feels really strange. So maybe this is overwritten in some other place? 26915. So it doesn't look like it. Let's look at the check serial function again. Actually, if we just like go down into the check function that verifies the final serial. Oh, maybe I'm actually off by 1 here, it seems. So maybe the input is actually but that feels really strange. Okay, let's actually properly look where this input ends up, like at what exact address. So we can go back to the code that gets the here. We do a breakpoint here, breakpoint. We restart this whole thing, run the program within this input. Okay. Oh yeah, the breakpoints disappear. You have to. Okay, and then we run a check. So this address 3E6. No wait. To BB. So this is where we put the input. Yes, that's correct. Okay. Now I at least fixed the decompilation, so it looks good. It was just about type thing in IDA. But this really makes no sense because like on one hand we need to have this to be a dash, but here it tries to look for it in this table here, which it will not find. That feels contradictory. But okay, but let's do this then. Let's say that we append, since these are after each other in memory, we append the current serial, or like maybe we just say like table2 is table plus serial, and then we find the index of that, and in that case table so this is like the offset 1, or like the I in the code, and then the serial should be table2 I minus 50. Okay, gives us something actually, so let's continue in this. And then we should not forget here that the target serial, so these two should just be the same, so we'll just do this twice. Okay, gives us something. And then we're looking for the fourth character of the name. We're looking this up in the table. So index name, yes, +9 +29. Okay. So we have to continue doing this, maybe. Oh, this should not be. Sloppy coding. Should of course use the correct variable here, otherwise it will not work. But we're supposed to add a dash here as well. And we add those, and this was -14. So, okay, we're getting something. And then another dash. And then we're going to calculate these values. So basically we are looking up we take some indices in the target serial, we look them up, add 18 or 17, and oh, okay, that's, but this is not actually used anywhere, it's just, okay, let's check if that's actually true. Okay, so we loop here, which will only modify EDI, but EDI is not actually used. So if this is actually correct, then we're just like taking these indices and repeating them. So okay, so now we have written something that generates something, and I have no idea if this is correct, but at least it doesn't crash. So let's just like let's just try it. Let's see if we are lucky. So 68 J5 PPF XLOU 0 JP-J. Nope, that's not correct. But at least we have something to work with. We can see, like, let's see where it goes wrong. So let's go back to the generation algorithm here. Okay. So we're gonna put a watch on the generated serial. It's stored at okay, here. So we're gonna follow it in the dump. Okay, so So why is the data already here? It's maybe from the last run. And why doesn't it match what I input? So let's take a look at this again, so that we're not missing any. Let's look at the input data as well. So we put this, we put an observer on that one as well. It's at 31BB. Oh, that's the table, right? Okay, so okay, so here we should have reference to the input, right? Input serial is at E3. So oh no, oh, we should have this. Okay. There we have it. There's the input, and we should also go. That's the input serial, and then we should also have the input name, which is there. Okay, so we have the target serial, the input serial, the name. Okay. Let's look over this algorithm again. Let's actually start over this check. Can we just do like a fill or something? Just yes. Okay, nice. So now we have we really see when stuff is modified. So this should be like this. So the first 5 characters, they are consistent with what we predicted. And then so what we then get is so the 6th character should really be the same as... Oh, that's an O. Did I miss... Was there like an off by 1 in my... Oh yeah, of course, there's a null byte. So when we do this, we have to do like this. So then we have a new proposed value. Let's see if that works. This should be OOAZ, and then it should be LOU0-JO-J. We do a check again. Yeah. So the mistake I did was that I forgot the gap between the lookup table and the input serial. So this is now a working keygen. So let's just verify this before I get too happy. Let's do another name. So we get another serial for Matthias, and he should have serial HJG700AZ 6XPPGOG. Yeah, it's good if you remember to add the dash as well. Yeah, congratulations. Okay, it seems like I have a working serial key for this now. So I would declare this a success, and just under the 2-hour mark as well. Wow, that took slightly longer than I had anticipated, but yeah, let's like just recap then maybe like the whole 3rd step here. So basically, after we had like finished all the unpacking stuff, we found this dialog handling function, which takes the inputs of these two these two fields, the name and the serial, checks the length of them, and checks that the serial input is exactly 19 characters. Then it generates like a target serial, and then it compares your input serial against the target serial. So the generated serial is generated through this function, and the first part here is it looks up stuff in a table depending on the length of your name. And then this part is a little bit tricky. It like loops past the lookup table, because the interesting thing here, it uses the 5th character of the input serial, as an index. But this is a fixed constant here, so we already know what it has to be. So it tries to look it up in the table. So it tries to find the dash in the table, but there is no dash in the table. So it will continue looping beyond the table and into the already generated target serial. And there we know there is a dash. So this will always result in the same constant, which then is used here as an offset into the table. And here it says like the 5th character of the target serial is, or like this, the 6th character of the target serial should be the same as the 7th of the input. But the input here, of course, has to match here. So these 2 lines is just basically saying that both of these should be equal to this. And it adds a dash. And then down here, it takes the 4th character of your name, looks it up in the table, uses it as an offset to generate a few more characters. And then it does some looping, but this loop variable is never really used. So the only thing that's relevant here is like it just copies like previous parts of the serial and reuses them. So yeah, that's the way it generates a serial. So I re-implemented this in this Python function, and now we have a working keygen for this crackme. Yeah, this was the first time I did anything like this, so I don't know if you enjoyed it. Let me know if you have any comments, like how I can improve. I guess should be like I guess I should like maybe try to explain my workings a little bit more detail while I work, but it's kind of challenging to like formulate coherent sentences about what you're thinking about while you're thinking about it. So yeah, anyway, I'm gonna stop this stream now. Hope you enjoy this. Thank you.